Problem 1 of V belt. So example 2.11, a V belt drive transmit 10 kilowatt of power from pulley of 200 diameter mounted on electric motor running at 720 rpm to another pulley mounted on compressor running at 200 rpm. The service is heavy duty, ranging from 10 to 14 hours per day. Center distance between the pulleys is 600 mm. So this is the given data. So now we'll solve this by, so given data, as you know, first we should write the given data. This is type 1. So here power is 10 kilowatts, D1 is 200, N1 is 720. So motor is always N1, and diameter motor is pulley motor is 200, that is D1. So N2 is 200 rpm, C is 600. So now, so first step to find D2 or D1 here. So in here D1 is given, so we'll find D2 here. So it's the ratio N1 by N2, D2 by D1. So we'll find, or N1 D1 N2 D2 formula, we'll find D2. Therefore D2 is 720, that is capital D, diameter of larger pulley. So next, step 2, selecting the cross section of the belt. So for that you have the formula DE equals to DP into FB. DP is nothing but D1. So now to find FB, so first take the ratio of N1 by N2. So first take the ratio of N1 by N2. So N1 by N2, 720 by 200 is 3.6. So for this 3.6, so the table, page number 307. So on this table, that's 22.29 to find the FB. So it is 3 point, means it is 1.949 and over, means it is 3 point is over. So FB is 1.14. So FB is 1.14. Therefore DE equals to 200, that is D1. DP is D1. 200 into 1.14 is 228. Now DE is 200. So corresponding DE to 200 on this table 21.24. So 228. So 228 belongs to, so 228 and 240. So 228 belongs to C section. So this is our, now the required is C section. So our cross C section belt. Now velocity, third velocity is pi D1 N1 by 60,000. So pi D1 N1 by 60,000, we have 7.54 meters per second. Now step 4, power capacity of each belt. So after selecting the cross section, that is, so since our cross section is C, so we have to use this formula for power per belt. So N dash equals to V into 1.47. So to use this formula, which we get in the data book. So we will use this formula, that is 21.32 equation number. So using this formula, substitute values of V and DE, we will get the N dash. N dash is 4.4 kilowatt. Next, number of belts. So number of belts formula, step 5, number of belts formula is N into FA upon N dash FC into FD. Now to find FA, so assuming it as a, so table 21.28, assuming it as heavy duty 10 to 14 hours per day, FA we can take it as 1.3 from the angle. So now to find FC, so first find the length L. L equals 2C pi by 2D plus D, D minus D the whole square by 4C, 21.3 equation number. So we get 2757.8. Now from table 22.27, so this 22, sorry, not 21.29. So the nearest value of 2757 under C section, under C section, (2723). So we have 2723. So the nominal inside length for this is 2667. So therefore the nominal inside length for this is 267. 267, that's inside length 267. So for this 267, from table number 22.27, so 2667, so under C section it is 0.94. So therefore our FC is 0.94. Now next, to find the angle FD. Now to find FD, angle theta is 2 cos sin of t minus d by 2c, that's 21.45. So find theta. So that is theta is 128.64 degrees. Now for this 128.64 degrees, in table 22.626, So 128, nearest to 128 is 130, so 0.86. So 130 0.86 for VB belt. Now substituting the values of and n, total n, and FC dash FC and FD, you get I equals to number of belts, I equals to 4. And the correct standard distance formula C is 21.39. Substitute the values and get the correct standard distance. Therefore, specification of V belt is to C 267. C is the number of C is the cross section. 267 is inside nominal length. And for this, from table 21.29, so W22, and thickness of the belt V belt is 14 mm.